We're now going to look at lesson 2-2, dimensional analysis. This is our first move into kind of some algebra notation. And so we have to kind of also connect this algebra to our fraction arithmetic that we do with fraction in terms of canceling things out. The skill is called dimensional analysis because we use what we call it's also called unit analysis. And so here's some terms here: unit analysis, unit factor conversion, but most of the time it's mostly known as dimensional analysis. Dimensions meaning that you have these units involved in this problem, and we're going to have to do some kind of cancellation or some algebra with it, and that's where the analysis comes in. One thing we need, though, in order to do this, something you need to know is something from fractions, that a fraction, for example, equivalent fractions or expressions, when you divide the same thing divided by the same expression, it equals 1, regardless of what that is. So you can see some examples here of that. 7 divided by 7 is 1. 7 feet cubed divided by 7 feet cubed equals 1, which that has to do with volume. Just old algebra, 3a divided by 3 equals 1. The same thing divided by the same thing, right, with equivalent expressions of the numerator and denominator is equal to 1. And so this idea, we use this idea in dimensional analysis. When you multiply something by 1, the value doesn't change. So if we were looking at some rate, $4.99 for something for 2 pounds times 1 would still equal that. So this is some basic arithmetic that we need in order to do dimensional analysis. We need to understand that. Here's another way of looking at something by 1 that doesn't look like a 1. 4/5 is equal to 4/5 times 2 over 2. This here equals 1 right there. 4/5 times 1 would equal itself. However, 2 over 2 is equal to 1. So when we do the multiplication, top times top, bottom times bottom, you get 8 over 10. And so that's why in mathematics, why those two are equal to each other. It's because I multiplied by 1. It just looks different, but they're equivalent fractions. And so when multiplying fractions, if a factor occurs in both the numerator and the denominator, it can be divided out. So there's another way to kind of think about this. The common factor may be a number or a variable. So here's an example that you can look at as we do some arithmetic here where it gets simplified, where this becomes this over here. So you want to analyze that, how the ones disappear because anything times 1 is itself. And so these are the key things to unit analysis or dimensional analysis or unit conversions, because what we're going to do is we want to convert, we want to end up converting from feet to miles, and we do unit analysis. This becomes important in a lot of other professions, especially nursing. And so that's what we're going to do in the following examples.